What we're going to try and do is figure out how far apart speed bumps should be.
Traffic calming provides the context for this problem, designed to help students develop their skills in mathematical modelling. Their challenge is to model a situation which allows them to suggest what spacing the speed bumps should have, to restrict the speed of cars to below 20 miles an hour. To begin, the teacher allows students to develop their initial model, which later they will be invited to refine. First then, to think about the relevant factors and the assumptions they need to make.
S divided by 2, it stops accelerating. Does that make any sense?
Can't define acceleration is equal to the rate of deceleration.
Oh, I guess it could. Yeah.
I guess we've got to make assumptions like that in order to get an answer.
Students needed to make assumptions based on what they knew and appreciate that our model starts very, very simple. At some point. Okay. Once the students settled and they got used to this idea of we're creating a model, became comfortable with the sorts of things they need to look at. One of the students bringing up the idea of constant acceleration.
It's going to start at 5 from the previous speed bump, is it?
Okay, yes, so starting at 5 from its previous speed bump.
Constant acceleration was an assumption many of the students employed in developing their initial model. Here showing equal time allocated for accelerating and decelerating between the bumps. In adopting this, they also assumed that the car would be capable of accelerating from 0 to 60 in 10 seconds. This enabled them to calculate and propose a solution.
This is going to take us...
Halfway.
That's going to take us halfway. So halfway is the 14 metres. So twice it, 28 metres.
28 metres then is their initial suggestion, based on their first simple model. Now to evaluate.
How reasonable is the answer? Is it an over or an underestimate? We ended up with 28 metres. Well, how far is 28 metres? And then relating it to car lengths. Does our model of 28 metres, 9 car lengths, seem reasonable? Think about your experience in the world.
Is the solution reasonable? And can the model be refined in some way that improves it?
What do we think about our simple model? What can you tell from the graph about any of the other assumptions that we made?
That you go immediately from accelerating to decelerating.
Could you have a very quick conversation on your tables, sort of 30, 40 seconds? What improvements could we make with our model?
Road conditions as well, because that could affect.
Yeah, so the curve would go up, straight, and sort of down.
Okay, so it doesn't go straight from accelerating to decelerating.
Yeah, so you lift off and
That
then
it wouldn't
coast a bit.
stay at 20 because you would accelerate.
Yeah, to be fair, when you're driving, you actually go up to
Well, he's
the,
going to drive flat out and
then you go back down again, so you don't like.
so you have a bit
Yeah.
of curve at the top of the graph.
Like take your foot off the accelerator and slow down, if you know what I mean. So there'll be like a curve there, and then you'd apply brakes like slowly over the rest of the distance.
So you're going to want to like accelerate fast,
Yeah.
come down quite slowly.
Okay.
Until you get to the next speed bump.
What do we think? Are we happy with this?
That's still going to be half the time, isn't it?
Is it still going to be half the time?
No, it would be.
No?
No.
Yeah, it would be accelerating much faster, so the time will move shorter to get to that. And
Okay.
So it's going to be.
Is that going to affect the distance?
No, possibly not. Because you're still, even if you accelerate quicker, you're still decelerating at a slow rate, so it's still going to be the same distance.
All right.
Surely.
Surely, maybe.
You always have to go from 20 miles an hour to 5 miles an hour. So
Yeah.
Some of the students were quick to question, but is something different going to happen? Is our negative acceleration or deceleration going to be slower than our acceleration? What do we think? It'll be quicker?
Brakes tend to slow the car quicker than you could accelerate.
Okay, the brakes were slow. So you're thinking that this graph should be different? They want to spend quite a long time looking at the style of driving, which we need to drag the students away from a little bit because it's difficult to account for. So up here, we've got a bit of a curve
Yeah.
because the acceleration will slow a little bit.
Yeah.
And it's curved on the other side as well?
You can't decelerate at a constant rate perfectly when you're driving, so you might alter so it'd be a curve. 'Cause you
Okay.
can't control it that well.
How much of a difference are those two things going to make to our model? How will these affect the distance?
In refining their models, students may offer alternative approaches, some more elegant than others. Encouraging students to explore the appropriateness of these provides opportunity to draw on a wider range of mathematical skills, developing their understanding about when to and when not to apply more sophisticated techniques.
It's getting used to the modelling cycle and understanding when is a simplification necessary and when is it an oversimplification. So with the new specifications, students are going to be asked a lot more about modelling their mathematics, either within a mechanics background or just for something obscure. So they've got to look at how they can make assumptions and then what effects each of those may have, and looking at the context of the questions as well as the maths involved.